Scale Draft Talk version 1 and go. So Linux and its microprocessors pre-1996. The question is, why Linux? A lot of questions here, but as we go through, you'll understand. So we're just going to get right into it. Before we go any further, though, I want to have an error page, and so I really value accuracy. So you can go there and you can, if you find any corrections or anything like that, I want to make sure that I don't have anything erroneous going into the record. And so that will be available as soon as this is done, and then I will link the video back there when I'm done. So before we start, this is a general talk. We want to introduce some of the players here, assuming that you don't know too much about any of this stuff. So BSD is a Unix originally popular at universities with early networking support and ultimately baseless legal accusations. It started in around the 1970s or so. There was another version of Unix called Minix. It was founded by a guy named Tannenbaum in the mid-80s. It's going to be important for our conversation. And then there's GNU or GNU. It was founded by a leftist out of MIT who wanted to do cooperative-based software. And then, of course, there is the star, Linux, which is a GNU Unix clone built in Minix by college students in the early 1990s. All right, so let's start out with the present. We all use Linux, but how did that happen? So there is a common story that, I was supposed to use the script over here, so let me go over here. We all use Linux even if we don't know it. Whenever you see a machine reboot at a grocery store or at an airport, it's like, oh, hey, there's that penguin again. Linux has arguably become the most ubiquitous operating system, but how did that happen? So we have this one, the common story, which is a 21-year-old posting to a news group in 1991, and everyone else came through. And this is his famous post talking about how he's starting an operating system. At this point, it wasn't even called Linux, it was called FreeX. So he didn't really have a name for it at the time. Well, this all sounds reasonable. 21-year-olds that are doing side projects, they mostly just, dominate the globe 30 years later. So actually, no. That sounds ridiculous. I don't believe it at all. You're saying a college kid with a hobby project started a computer revolution by posting? No, this is not how the world works. And so there were many freest choices. Oh, see, I skipped that one again. I got to do this stuff. This is draft 1, all right? And I'm still going to post it to YouTube, to be honest. All right. No. I don't have it yet. That's it. Okay, so here there are many freest choices. You had Purdue ZNews, you had the Carnegie Mellon mock, which has gone on. There was a University of Utah mock. It's become the source of many kernels today, most of the Apple ones, in fact. You have GNU Herd, which was GNU's operating system that was officially announced in 1984 or 85 was supposed to be done, but it was supposed to, whatever. Then you had MIT Trix, which was supposed to be what GNU Herd was initially based on. Then you had in 87 a GNU OS potentially. There's a long Usenet discussion on maybe this would exist one day. And also 87 you had Minix coming out. And then in 89 you had a BSD called Net1, which then initially became 386 BSD, which we'll talk about later. And then in 81, maybe GNU Herd again. It just seems to never get done. So, in fact, there were many other operating systems out there at the time. Here's an entire list of them. These are only the Unix-ish ones. Oberon by Pascal's progenitor Nicholas Wirth is from 1987, and there are other minor ones I found references to in the back of magazines and long-forgotten Usenet posts, and they didn't even make my slide deck. But here you can see here's first various commercial efforts. I can use the mouse pointer, that's right. Some things are left out of here. Some of these are complete systems. Others are just kernels, such as Mach. The point is, it wasn't Linux shouting out from the wilderness. There was an active and vibrant Unix on the PC ecosystem and an underground that predated him substantially. And it's also an underground which hasn't arguably had a long direct existing impacts. So products such as very popular commercial products such as Coherent and Xenix were hot stuff at one time, and now only scholars and historians know about them. So that really means that this guy was the winner of the Unix war. And not only on the microcomputers, but also on all classes of computers. I was only able to find one commercial Unix still around, except for the special case of Apple, and that was Zinnuos UnixWare 7, definitive in 2018, with the last release, as you can tell, 6 years ago. Actually, it was 7 years ago, 2017. And it looks like it can still be purchased, and that's it as far as commercial Unix vendors are that aren't tied to hardware such as Apple. So there's another part that was given to all of this and of why Linux is successful, and there was something called the BSD USL lawsuit, and essentially there was an accusation that the people that had BSD had some of what was AT&T's copyrighted code still in it, and they held them up in courts for a 2-year period in the early 90s, but in some crazy night court drama. But it doesn't make sense. And to get a little bit more background on BSD, again, I said it's from the 1970s, and there's a lot of people involved in it, but the two that we are going to use for our story are Bill and Lynn Gillitz. And the question is, why didn't this theoretically win the Unix war? And this is what's usually given, but it doesn't make any sense because there was a SCO Linux lawsuit that was around for 13 years, and that really didn't delay Linux. So that really doesn't make any sense. And then you have some BSD math that doesn't really, because Net1 is from 1989. That was 2 years before Linux. And so they technically got a head start. Bill Joy started BSD in 1976, and so it's a 15-year head start. And then what about the 30 years since then? If you ever use BSD, it's great, it's clean, it's well built, it's stable. If I was ever to teach an operating systems course, I would use NetBSD source for my students. I think it's some of the best code out there, but it didn't win. So if we take it at face value, that there was a 2-year-old on, what the hell is it? What is that? There was a 2-year-old. This is not. This makes no sense. I see what I did. If we take this at face value, that there was a 2-year hold on BSD, then we should go over to, say, Usenet and see a fair amount of silence during the lawsuit period. So if we want to, the whole theory here is that there was, as the lawsuit was in the courts, there was kind of a freeze on development, and that's when Linux sort of sprinted ahead of the BSD. However, I could not find any evidence of this. This is just a small snapshot of activity. It was lively and vibrant. Some of the authors had political statements in their SIGs against the lawsuit, but there's no really evidence of a chilling effect on the BSD. I mapped out the velocity of the 386 BSD Usenet articles and tried to see if there's any noticeable decrease or change in the velocity of activity correlated with the court case activities. And although I'm not a data scientist by any means, the two looked completely unrelated. Also, the release schedule didn't seem to have been interrupted in any way. There was also a number of articles across Usenet on both Linux, Minix, and BSD groups that had titles like Linux or 386 BSD. And people listed out in replies comparisons about which ones they should choose. And although many included minutiae such as specific hardware or protocols, none had references to the lawsuits as a reason to choose. So after being forced to reject the hypothesis, it is often given, but there's no contemporaneous material evidence to support it. And that's kind of, and if you want to tell me how wrong I am, then please go to URL and tell me. I want things to be accurate. So we have to say that there is this theory of a victorious penguin. And regardless of what you want to say about BSD, Linux has become at least an order of magnitude more prevalent than it. So we can have two reasons for that. The first one is a 19th century approach to history called the Great Man Theory, and the second is a 20th century approach called The History from Below, or often Social History. And let's just look at the Linus is a once-in-a-generation genius approach on the order of Einstein and Isaac Newton. And this one actually sucks because it says that there was a great and glorious thing happen, but you can't do it because you don't have the right genes or whatever. But I'm not Linus Torvalds, you're not Linus Torvalds, so we should stop being ambitious because we're probably going to fail, and we are not that great man. And there's another one, which is one I like, and it's the no superheroes required one. And using the power of syllogisms, mere mortals did this, we are mere mortals, therefore we can do it again. And take that, Socrates. So I like two. Number one is a much shorter speech. There's an 1841 book by a guy named Thomas Carlyle titled literally On Heroes, Hero Worship and the Heroic in History, positing great men should rule and that others should revere them, presenting a Horatio Alger story. And if I did that, this would just be a fawning biopic. However, we have a much harder task ahead of us because we're going to try the social history approach. And the value of that is that if we study the past to create a better future, then we can maybe find out how to do it again. Maybe. So in order to do this, we have to have posits, not hypothesis, if you will. Let's just go over to the terms. So these are some more things that are going to pop up. If any of this stuff is new to you, please look at it. I'm not going to go over it. Maybe the radical politics that started the microcomputer revolution could not mainstream software from the same milieu. Maybe Linux was the act two of the personal computer revolution. If the central will not hold, if things fall apart, and mere anarchy is loosed upon the world, we might as well make it productive and get a nice operating system out of it. So maybe a free Unix needed a hacker and Unix underground culture to be vibrant in order for it to be supported and built. Maybe there needs to be an increased power of microcomputers, ones with hard drives, or you know the processing features in order to create a nice Unix environment. You have to have a wide availability of the internet, and maybe something that's not legally problematic to harken back to the BSD. So maybe chapter 3. Oh, maybe not. Did I have that? Oh, I do. Cool. So there's these other things that are presented as why it didn't happen before or afterwards, and I just want to dispel those. The first one is Unix was thought to be too complicated, which is not true. It had been praised for simplicity and elegance a lot, and maybe it was called complicated because the source license was $200,000. I don't know. And anarchist models were thought to be impossible. That's also not true. There were lots of anarchist models before that, going back to the People's Computer Company of 1971. So it goes back quite far. So anyway, the pretext. So we're gonna, where are we at? Okay, so Unix's first paper came out in 1974, and I want to have some takeaways here that are also going to be relevant in our discussion on Linux. The first one is, these are quotes from the paper: leverage, don't invent, doing beats planning, you should address needs, not desires, and you should use early and use often, also called dog fooding. Each one of these things I can criticize as maybe bad engineering practices, but that's not the point. Maybe all of these work well together, and that's kind of, there might be some kind of what middle management loves to call synergy about this, so we'll get into that. So the first thing that we have to look at is software reimagined, and these are only meant as examples. And so as time passed, this slide is in the wrong order. I think I need to swap it with the next one. I think this one should be first. Okay, so let's try to do this one and then go back to the other one, and then let's see if that works. So, yes, this is what I want. So, let me write that down. I should be writing this stuff down. Hold on. Stop the clock. Make expensive things cheap, swap with software reimagined. All right, so Essentially, as technology progressed, people wanted to have some of the compelling features from the more expensive machines on the cheaper ones. You can see this stuff in Innovator's Dilemma from Clayton Christensen, how he talks about how, people that are getting the cheaper things wanted to do some of what the more expensive things do, and eventually it gets there. And there's something called Bell's Law. And roughly every decade, a new and lower priced computer class forms based on a new programming platform, network, and interface, resulting in a new usage and establishment of a new industry. This is from 1972. They stated that. So that would lead us to software reimagined, which now makes more sense. And these are only meant as examples. The point is the velocity of computer progress went faster than people's needs. This can be embodied in another thing called Grosh's Law, which held that more in the 1960s through the 80s, and essentially that computer performance increases as the square root of the cost. And so that means that if I double the cost, then I'll get 4 times the performance. This was arguably somewhat true. Who knows? But when you combine that with Moore's Law of the 80s and 90s, that transistors per chip doubles every 18 months, then you can see how the industry would eventually eat itself through a multi-decade-long digestion process, to the point that now we have smartphones that are doing what the supercomputers once did, which is a natural sort of progression. So now I'm going to go into what Unix was about. Yeah, there needs to be more of a transition here. So I have to do that one, then I do that, then I do that. Yeah, it doesn't make any sense. I have to talk about, so do that one, then I have to do make expensive things cheap. Software reimagined, make expensive things cheap. Unix is a hacker's tool. That was the connection. So the connection here was that I was going to do software reimagined, yes. However, when new things come on board, they come in unpolished. That's it. However, when new things come in, they come unpolished. I wonder if I can still get it under 1 hour with all of this other crap that I'm doing. So, it means that as this transitional downward event happened, going from here down, or here, this yellow part, you don't have a lot of commercial or professional uses for it. You need to have people that really kind of know what they're doing. And that's another sort of point of Unix, is that there's no advertising, no support, no bug fixes, and you have to pay in advance. It was a nominal fee at the time, but yeah, you did have to pay a little bit for the Unix license. So there's a little quote from a 1984 paper by Dennis Ritchie. Anyway, so here is another sort of instance, is that Unix came in bottom up, and also Linux came in bottom up in the same sense. Linus Benedict Torvalds on October 5th, 1991, he wrote a post that said, "You also need to be something of a hacker to set it up. So for those hoping for an alternative to Minix 386, please ignore me. It is currently meant for hackers interested in operating systems and 386s with access to Minix. And focus is about intentionally ignoring." And I wish that it was nicer. Oh, that's not it. Focus. Oh. Maintaining focus is about intentionally ignoring. I wish it was nicer. Yeah. Okay. This is terrible. I'm so glad I'm doing this. All right. The problems. So at this point, oh yeah. So we say Unix. Okay. So here we say the problem say. So Unix is a success. It looks like we won. So yes, Unix is a success. It looks like we won. It came in bottom up. As the Gaussian and Moore's Law went forward, you had more dominance, and we're in the 1980s, and everything looks great. However, because it met people's need, then came the ruinous desire. There were a bunch of commercial vultures that would come in, and a bunch of companies. Here's a list of them. And then there were so many that you had to have these organizations that try to bring them back together. You had Unix International Open Software Foundation. And Unix International was a coalition between AT&T, which had the copyright on Unix, and Sun Microsystems. And then the other organizations at OSF, which came out with something called OSF1. It was based on some kind of microkernel. It was a complete freaking mess. And not only that, but as we saw beforehand when we said that Unix basically was a mini computer trying to mock the mainframe features, the very first port was going back up to the mainframe. And so it kind of, ate everything else as it went out. So that was important. So that is, So in order to sort of show how much of a growth there was at the time, the Unisys, and one of the mainframe makers, had an article in the September 7th, 1987 issue of Computer World predicting a tripling of Unix sales over a single year. So that was another problem. And then also microcomputers met IBM. And in 1985, Microsoft argued that Xenix would be a multi-user version of DOS, and Ballmer in 87 said they didn't see it competing with their plans for OS/2, which at the time was seen as the successor to Windows 1.0. I know things changed, but they didn't see that Windows 2.0 as actually becoming a product in 87. I think, I forget when 2.0 came out, but they were more focused on OS/2 being the successor to Windows 1.0 at the time. And in 1985, they were quoted as saying there were about 100,000 Xenix installations. And at the time, it required 12 360K floppies to install, which was seen as a big burden. And putting that in perspective for people that are kind of young, a 32 gigabyte $5 micro SD card is about 93,000 floppies, 190 meters stacked end to end. That's like a 2.5 minute walk. All the storage now in the size of your thumbnail and costs a noticeable amount. The point of that is that software distribution used to suck. And here's an example of it. So here's various forms of software distribution early in the day. You'd be really lucky if you had this Cradle modem. But here is a vinyl record that you could play and then hook the audio into one of your early micros. Here is another cassette. A lot of the stuff is done through audio. And here is some punch taped up here. Speaking of Microsoft, this punch taped that says BASIC 1.0 is from Microsoft. That's how they distributed BASIC for the Altier in the 1970s. Paul Allen made a loader as he flew to MITS in Albuquerque to demo it by using a hole punch on the plane in order to create new code. That's true. He had no idea if it was going to work, since even their BASIC had been written on an emulator that he and Bill made by reading some manuals. It took about 20 minutes to load the tape, which is software distribution used to suck. And when he got there, and of course it wasn't stored on disk because there was no disk. And so you just had to keep the computer on if you wanted to use it. And so it was crazy. So here's another thing. There was more about software distribution. We're going to quote Marketing High Technology by Bill Davidow in 1986. And it's not a product without a distribution channel. The device may have the potential to address the needs of many, but without specialist redistributors to put it in the hands of those customers, it will not succeed. Products are sold through distribution and not to the distribution. Here is a graph that talks about how based on the number of units that you're going to distribute, then the actual unit cost decreases over time. So if I was to create a lot of units, then retail would become cheaper. Or if I was to create a lot of units, let's say over SneakerNet, which is me handing out to friends, it doesn't really become cheaper. It's about the same price, regardless of how big it is. And so because retail was so expensive early in the number of units, there were a lot of sort of non-retail methods, because you wanted to lock in some of these older, lower costs, especially if you have something that's not going to be 100,000 units or 1 million or something like that. So you have freeware, shareware, and something that has fallen out of favor since then, public domain, and now we use something called copyleft. So we want to get into, all of the software in the 80s fell underneath this rubric, if you will. Even Minix. Here is the original announcement of Minix, and we snipped out a bit of it. As you can see, he is very adamant about saying this is not public domain. However, the publishers do not object to people making a limited number of copies. That's SneakerNet, for example, professors making copies of software for their students. This is relying on the constants holding. So this entire agreement is relying on there not being an easy, widely accessible internet, and it wasn't in 1986. You may make a few copies for your friends. If you want to sell it, you need permission from Prentice Hall. All right, that sounds fine. In the book, you'll find a postcard that you can use in order to order the software. That's the mail order that we talked about before, and please don't ask me. It goes over the labor of trying to create these looping floppy disks. And then he has his nominal price with the source code. So, I need another thing from there. Okay, so between that and say, okay. It's already in here. Even if Minix did have these owner's roles, because of the prohibitive logistics around software distribution, updates, especially customer-initiated, were fairly inconceivable. And so now we're going to look at that. And so based on the distribution channel, this is how hard it is to update something. So let's just say that I wanted to contribute a modification. So if it was, if I was the author, then if I wanted to do it through these distribution, then the only one that's harder is SneakerNet. But let's say if I was a user and I found a bug. Can I do it through retail? Hell no, I can't do it. Mail order, unlikely. Over SneakerNet, I guess I could distribute and then or modify a program, then distribute it to a friend. Over BBS, maybe, but it's hard to get it to the people that previously had it. You don't really know who they are. But over the internet, this is all easy. And so this is the easy one down here. When we're at this point, then all of a sudden forkers, me, and then the author can have lots of modifications. And so this is until most computers had hard drives, there were online networks which could provide the storage and communication necessary to unlock multiplayer online mode for software development game. Linux Benedict Torvald, again, in his October 5th, 1981 post, said that he said, "I enjoy doing this, and someone may enjoy looking at it and even modifying it for their own needs. It's still small enough to understand, use, and modify, and I'm looking forward to any comments you might have. I'm also interested in hearing from anybody who has written any of the utilities, libraries, functions for Minix. If your efforts are freely distributable under copyright or even public domain, I'd like to hear from you so I can add them to the system." So then he is encouraging this you and Forker to go back upstream, which was brand new at the time. And this was a sort of a Linux innovation. GNU didn't have it. So here's GNU, it's News Bulletin from 1987. And he says, easiest way to get a copy of GNU software is from somebody else who already has it. That's SneakerNet. If you have access to the internet, then you can get the latest. Yep, that's network distribution. You can order one. Okay, and that's mail order. And then they talk about the order form for prices. Of course, you had to pay for the tape and all the distribution costs. And they're also looking for donations because they are doing this in a top-down hierarchical way because they don't see the anarchistic way of this being able to go from being able for the forker and the you to contribute back upstream. This was still a very innovative thing at the time, and so that was a brand new idea. So we have to go to the next subject, which is the politics. And I apologize in advance for talking about politics here. So the first one is needs, not desires. Number 2. This is more about corporate politics and software development politics and any kind of, people being elected. So the idea here is that we have bugs, needs, desires, and aspirations. And as things become more abstract, if you will, it becomes harder to implement. So you can have an aspirational system that's supposed to, you can have the Steve Jobs 3M system, which is a megabyte of memory, a megapixel of graphics, and for it's mega penny is the last one, which is under $10,000. But there's another one to it. I think it's about a megahertz, or I forget what the third one is. I should look that one up. let me do that one. So, yeah, 3M machine by Steve Jobs. Steve Jobs. 3M quote. And another one, which we can use to emphasize the same one, is that there's only two kinds of languages: the ones that people complain about and the ones that nobody uses. So you have the aspirational versus these ones down here that are actually practical to use. So we're going to go to Software Revolution. There is a very famous letter that was written by Bill Gates to Bill Gates to Hobbyist Computers. Hobbyist Computers in 1975. And that is often misdistributed as the beginning of commercial software, which is complete bullshit. Commercial software arguably began in about 1955 underneath a company called SDC. And the real sort of modern commercial software split happened in 1968 or so, when the computer distributors got together and then decided to decouple software from hardware pricing. Before that, you went to the hardware vendor in order to buy software. If you didn't do it that way, then you'd probably hand it out or something like that. There was no real sort of commercial software unless it was bespoke. So, of course, there was contract software for Sage or whatever it was like that, but a kind of saying, there's 100 customers having this type of computer. Let's sell this piece of software to these 100 customers. That was not really big at the time until 1968, decoupling. Here is in Ada Datamation saying that if you do decoupling, you might have 100 bad OSs. And they said, okay, I'll do that. And because this was possible, that's what made Unix distribution possible. 1968. All right, so this made things super complicated. So because of that, that meant that all of these were having their own rules to it. So this is a really early diagram of Unix splits from it was written in 1994, but it actually goes much. It actually, it's about late 80s, and it's very basic. There's many others, but the whole thing is that, like, let's say that you wanted to have a SCO or V3.2, a Plan 9 or V8. Each of these had their own terms associated with it. Who can share it? Whether you can have the source code. What could you use it for? Whatever. All of these terms. And so it made it very difficult in order to find out what can I do, going back to the modifications and all those other kinds of distribution channel things that we talked about beforehand. How is that even possible underneath this? So there's another idea about this clean root design and public domain that we had, but those were also insufficient. And so Net1 was done through a clean room design where they didn't have any AT&T code, but it still bit them in the butt. They still had to go to court for 2 years, so that wasn't clean. And then you had a GNU Bulletin, which decided to define this new idea called copyleft, which is to have a legal instrument. Well, we also call this GPL by this day, with the freedom to distribute copies and modify the copies. Now, this is something I need to. So what is GPL? That is what it should be. License model, Software Revolution. So what is GPL? Now, there are many open source licenses, and I'm going to first. All right, let's go back to there. This is what happens when you don't have any edits. Anyway, so cannot concentrate. The question was, can we have something legally in the clear? That goes back to, oh yes. The question is, can we have something legally in the clear? That goes back to the fourth point of our posit. And Net1 is somewhat mysterious because it comes from BSD, and the people had seen the AT&T code beforehand, and there's all this other sort of like history that's maybe known and not known. Yeah, and the knowns and unknowns aren't really as well documented as we would like. However, Linux doesn't have that problem. So essentially, it's extremely online and public. And one of the reasons that Minix was insufficient. Okay, I really like this quote. Oh shit, I really like this. I really like the Prentice Hall quote, but it doesn't belong here. So, Prentice Hall quote doesn't work here. Essentially, the whole point is that, yeah, Linux. This is clear. Don't have to go into that. Yeah. Okay, this is something I need to work on. So I'm just going to skip over it, or I'll show them right now. So the license model is right here. I don't think I'm going to keep this one in here. I'm just going to do shop talk right now. Is because we're doing pre-1996, and yes, BSD existed. NPO, no. MPO, yes. Public domain, yes. LGPO, no. So we only have 3 of these things. I think this should be cut. Anyway. And this should be, yeah, it should be. This is an important one. This was an early one that I made. Essentially, the idea is that you need the source to be available. It needs to be shareable. It needs to be at no cost. It needs to be cooperatively developed. It needs to be a complete operating system. And at this point of what we're referring to, 92 or 93, only one kind of had it all. It's questionable whether Linux was complete or not. So yeah. Anyway, let's go to chapter 6. So, everything was too expensive. We want to make expensive things cheap again. So here's an article that I found about low-price workstations from Sun, where they're advertising a $7,000 or $6,700 workstation. That's not low price enough. We can get a 386 over here for $700. This is about the same month time frame. So the 386 brought a lot of nice features, and virtual memory, paging, pure 32-bit processor, up to I think it was 4 gigabytes of VM, and so just a lot of nice things that you could exploit. And Linux was really sort of the beat Microsoft and IBM to release a pure 32-bit operating system. Very interesting. There's also a debatably humorous adage about this concerning Andy Grove and Bill Gates. What Andy giveth, Bill taketh away. In this case, the new software Linux, and is consuming the increasing capabilities provided by the 386. One of the things we want to look up is the price of time, which is another kind of price. Price isn't only money, it's also time. There's a often sort of lobbed thing that free only if your time is worthless, and well, maybe not. So this is I have quantitative evidence for this thing, but I didn't include it in the slide because I couldn't figure out how to include it. But people quoting costs of doing work in 386 BSD and saying like, oh yes, I would be more than happy to do this, but they were giving these outrageous prices. And then Linux people said, yes, I'd be more than happy to do equivalent things, but they were giving much more modest prices that people could afford, and much more modest timelines that people could, afford with time. So the idea here is, in order to lower the cost of specific problems, you have to have all of these things. You have to be able to have more hackable systems such as Linux, have cheap experts, which was possible because Linux was done by college kids. BSD was done by people already working, professionals. The Bill Joys and the Jolitzes, people that went to college in the 70s. And you need to change the I to we, which you could do with Usenet by saying, we have this problem as opposed to I have this problem. And Calvin Moore spoke of this in 1959. I'm going to paraphrase by Pemberton on it, is that the more difficult and time-consuming it is for a customer to use an information system, the less likely it is that he will use the information system. So as the complexity of the problems become more intractable, the approachability of the lower levels of the internal systems become increasingly important. There's also something called Zipf's law of least effort, which also encapsulates this, the same thing. One of the ways I was able to do this was by recruiting new troops. And essentially the idea is that when you go from problem to solution to integration, it creates this kind of engine that can move your project from a hacker obscurity to Mount Ubiquity. Because as you see more problems, and if you're able to solve them and you can integrate them to the whole solution, then you have more other people's problems solved, newer users with fewer problems and different hardware. And by recruiting these new troops, you're able to exploit something called Reed's Law, which is from 2001. The utility of a large network can scale exponentially with the size of the network. The number of combinatorial subgroup participants from these larger collections grows more rapidly than the original utility of the groups that joined. So essentially, if some new group of people join, then they can form groups that are vertically and horizontally with other people, and then create committees and things like that. So Debian grew, right, from nothing to a bunch of things, and along that is where you go from a toy to tool. And so so everything starts basically at sort of a toy level before it becomes this productive thing, and it has to go through these steps in order to get there. You can do it commercially, and this is basically the cost of the price of the software and the price to actually develop the software. It becomes very expensive to get some critical infrastructure things, things that are run, at nuclear power plants, if you will, or on spaceships. So Linux really started off in the hobby, entertainment, and education things, and it's from Minix. But then it became a personal computer or a productivity application. Then went to business and professional uses, and then it went to critical infrastructure. Minix didn't, kind of stopped. And then 386 BSD, I argue, tried to skip it. And I think that's one of the reasons that I didn't do that well. Is you can actually look at, I analyzed 2.5 million Usenet posts that showed that there was more commercial 386 senders and more academic Linux senders as they did this transition. And so over time, you can see that the EduLinux decreased, the commercial increased as this transition went up over time. And I also posit this thing under what I call the Linuxist revolutionary theory for Leninists. So you have a hacker vanguard that then creates a personal computer proletariat, that then creates a business-oriented bourgeoisie, and then the prohibitively assiduous aristocracy up here in the critical infrastructure systems. And there's also, total votes and hackers in general tend to create what Alan Perlis called the Turing tar pit in 1982. At this point, everything is possible, but nothing of interest is easy. And then pulling yourself out of the tar pit from a capable system to a usable system requires these stepwise user adoptions in order to work. So, in order to do that, we are going to make expensive things cheap. Number 3. And we're going to define effort as an amount of money plus an amount of expertise plus an amount of time. And essentially, as software capabilities go up, the effort demanded is going down. And the utility function is roughly, utility function is roughly software capabilities divided by effort demanded. Sometimes they both increase over time. Blender, for instance, is highly capable software, but also takes a lot of expertise to use effectively. Many mobile and web apps, on the other hand, actually remove power user features over time to make the product require less effort while also making it less capable. Still, other software, APIs and frameworks come to mind, can have the Fred Brooks second smell system smell. They have a new version that's far more difficult to use and leads to inferior results, thus being the inversion of the grass and decreasing the utility of the product. Examples of such grisly monstrosities have been intentionally withheld. So, another way that you can actually do this is to try to have more on-roads, more on-ramps to these different kinds of user groups that we saw before here. Because when we get up to business and professional and productivity and personal, these groups balloon outward into a great sort of tree, a fractal, if you will. And one way to do that is we have our bizarre method that is done through the distribution model in Linux. I need to introduce this before I talk about it. And because we have 500 different distributions, that means that there's more on-ramps to using it instead of BSD, Windows, and Mac. FreeBSD, there's only FreeBSD. NetBSD, there's only NetBSD. Well, Linux, there is 500 of different things. So, I am at 45 minutes. I don't know if I'd be able to do this. We'll see. The packets. So, we're going to quote, this is from Andy Grove, only the paranoid survive. He posited that the transformation of the computer industry went from these vertical stacks to horizontal stacks over time, where we have IBM DEC and all these different things, Data General. And then over here in the 90s, we have the distribution channels, as we talked about beforehand. And this is also with the software and hardware split that we talked about in the 60s, and all these things right here. But this is not what happened. What actually happened is that supporting everything became too expensive. So Windows decided to be the standard. OS2 decided to die. Mac decided to go back to the vertical stack that we saw beforehand. And Linux said, well, how are we going to do all of this stuff? Well, we can do it with free labor. Where are we going to get the free labor from? There is something called the Eternal September. Essentially, the idea is that as the internet grew, you could get more people on board. And so let's say on average, you can have, 0.1% of people actually contributing to Linux. As that number keeps increasing, well, that small number down there also keeps increasing. So there is a benefactor of this, and it's attributed to something called Linus's Law, which is actually by Eric Raymond. Given enough eyeballs, all bugs are shallow. There's empirical evidence for this to be a tendency rather than absolute, as many substantial open source bugs go unnoticed for a long time, but that's really out of scope. The idea here is that you needed to, in order to have a supporting growth of internet, you needed to have a way to run the ISPs to get people online cheaply. You needed a way to run the web server cheaply. And then you need to have a networking effect that directly improves its quality cheaply. And so all of these things together led to basically Linux being the best suit. And in order to bolster this as evidence, we are going to look at some of Linux's early non-Linux contributors. So he did an initial code announcement in 1991 on October. And then the first non-Linux was also in October by a guy named Wierzenius. But then in November of that month, a guy named Peter So from MIT made a contribution. Theodore So. And then also that month, a guy named Galen Hunt from University of Utah. And then in January, you had Drew Eckhart from Colorado Boulder. And then in February, you had he announced that it would become GNU software. Most of the early contributors are having .edu, or they were otherwise college students, so they were all very young, which is why initially I said Linux was developed by college students, because empirically this is absolutely true. While this was happening, the host count on the internet doubled to 1 million. The backbone goes to a T3, which is a slow by to stay standard. You had the www, the Mosaic start. You had the commercial ban was lifted. And so that means that the host count started doubling at about 3-month clip, which means that you needed to have a quick, dirty, and mutable solution that you needed like right now. and Linux was really the only thing that occupied that. Going back to that is where I should put. That is where this fucker goes. Apparently you need them all. Goes there. All right. Hey now. That goes after non-Linux contributors. Ooh. All right. So that means in the past 30 years, we basically have these paradigms. Windows basically has the vendor trying to do the support. They don't do the support. Mac says, sure, we'll do that vertically integrated if we control everything, and Linux basically eats it up, nom, 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 nom. So that means you find Linux in cars, phones, spaceships, toasters, robots. Just about everywhere. Here's some graphs. This is supercomputers, and now Linux dominates. Here's web operating systems. I don't know why Windows is still over 10%, but supposedly it is, even as of 2023. So that means that we have this victorious anarchy, which I should put after distributions. So this is from Clayton Christensen, basically saying that there are these many strategies that you can do as these needs change. And you could, I don't know, you can go up market, you can stay with the customers, you can do all these other things like that. But since we have all these different distributions, we can do all of these at once, which means that you have a bigger tent and you can do the politics of more people, which is why I should go in the politics section. Yep. All right. The perhaps. We're almost done. Even with all these edits, I've almost done it. So we're going to go to what does the unlikely success of Linux tell us about how to feature? There is something called Crossing the Chasm by a guy named Geoffrey Moore in 1991. He basically, this was for commercial products, saying that there's this early market, and then there is this thing called a chasm, and then there's a mainstream market afterward, and you have to jump over it. And there's many reasons for that. Let's just take electric cars. You can say, okay, electric cars are at this point right here, but then nobody can find a charger. It's still going too slow, or, you know, it's too expensive for me. There's all these pragmatic complaints about electric cars at this moment, and we're in a chasm. And people say, oh, look, the sales went up like this, but now they've kind of dropped a bit, and electric cars, yeah, we're there right now. You can also find that in cell phones, in smartphones and in the original cell phones adoption. You can find that in broadband as well. Anyway, well, I'm going to propose something called the Crossing the Open Source Chasm. I lost my 64. Let's see. I need to actually put notes here. So in the Crossing the Open Source Chasm, essentially it's you start a project out of passion, and in order to then get to the next step, passion can get exhausted. You need to have more people, and then those people become enthusiasts, and they are the music makers, they are the evangelists, and then we have a chasm at that point, because you need to get something to be a practical or pragmatic product at that point. And when you pass that, then you can get to the business, and then eventually you get to enemies, which is Microsoft, for instance. And so this is how you create a successful open source product, maybe. The problem is that this isn't really easy to quantify or to point, because the reality. So let's just look at this thing. Where is this hole? Is this 1993, 92? Can I say it's like between Linux 0.96 and 97? Like, you really can't do this. It's tough. So this is very sort of fuzzy. The reality is it's really ugly, confusing, and illegible. You really don't know what's going on, even if you seize market things and do these attributions. And maybe they don't actually cross the chasm. Maybe it dies. Maybe you have something like this and it's a gigantic chasm. I don't know. It's tough. So how can you conclude? Well, you really can't. We can choose stories with the strongest evidence, and hopefully we can do better than fiction. So one of the things is it looks like that vision plus failure might equal success. GNU Hurd, which I should put more data on here about, it led to Linux. Ted Nelson's Xanadu, which is out of scope here, but that's the predecessor to the WWW. You have Xerox Alto, led to the modern desktop, and so it looks like that maybe you need to have these strong visions in order to get to. Yeah, I need to add this one. So the perhaps one is that strong IP enforcement on strong visions diminishes its chance of success, and you must let go of that which you love the most. It's really important. The second one is that the right pushy one is that let's say that you have a project right now and it's your passion project and you're in that point. That means that you are in the first year and that you are way early, definitionally, because you are not in the mainstream. There's not 100,000 people using you. You aren't on the front of magazines. There's no documentaries about you. So you are in that first thing. And aggression in that point of your idea, not the kind of bad aggression, but aggression of your passions is the key to success. Think about Richard Stallman, right? He was very aggressive. And the only way for that to happen is that when you commit to others, because your revolution needs armies. As you saw beforehand, Linux was not shy about trying to get other people to start contributing. So it means that whatever you're doing will probably take years, and it will manifest differently than you thought. GNU operating system is not done by the Free Software Foundation, and that's just how it is. So you have to love your ideas, but avoid the codependencies with them, these overzealous commitments to them. So next steps. This is from Peter Sells, Core Essential Unix. Do one thing and do it well. Work together, handle text streams, because that's a universal interface. That is one version of Unix philosophy. It's kind of a joke, but it's kind of not. We're going to take Tracy Goddard from The Soul of a New Machine, which was a book published in 1981. It's kind of a long quote, but it's worth it. Looking into the VAX, West had imagined he saw the diagram of DEC's corporate organization. He felt the VAX was too complicated. He did not like it. For instance, the system by which various parts of the machine communicated with each other. For his taste, there's too much protocol involved. He cited that the VAX embodied the flaws in DEC's corporate organization. The machine expressed that phenomenally successful company's cautious bureaucratic style. Was this true? West said it didn't matter. It was a useful theory. The whole point is that the organizations that we have, or how we choose to organize, gets reflected in the software we build. And the software we build goes back to how we're going to organize. There is a Winston Churchill quote, which I'm going to put in here, which is, we shape the buildings and thereafter they shape us. All right. Or maybe, here's another version of the Unix philosophy. Make it easier to write, test, and run programs. Interactive use instead of batch processing. Think about this in organizational and how we communicate with each other. Economy and elegance of design due to size constraints of how we organize. And also creating a self-supporting system. We have to care about each other. We can go to Melvin Conway's 1967 law for this. Organizations which design systems are constrained to produce designs which are copies of the communication structures of those organizations. Raymond paraphrases as if you have four groups working. Eric S. Raymond. Eric S. Raymond paraphrases as if you have four groups working on a compiler, you'll get a four-pass compiler. It's kind of a joke. So, perhaps last, we studied yesterday to create a better tomorrow, and the future is ours to make. Probably. Hey, 58:35. Look at that. I still got an under an hour, even with all those mistakes.